Hi everybody, and thank you for joining this presentation. I'm going to talk about how we were able to manage thousands of Kafka topics across multiple Kafka clusters. But first, let me introduce myself. I'm Antonio Tomac. I'm a member of Team Kafka within Infobip. We are responsible for maintaining all our clusters on the platform. And I work as a Java and Kotlin engineer. And I am a person who created a tool called Kafkistry. You're going to hear more about it in a minute. And this presentation will contain the comparison how we did things and how we operate over our clusters before we had Kafkistry in comparison how we do it now. And you'll hear some details about Kafkistry, for example, what its basic idea behind it, some key architecture, what are core functionalities, and how it evolved through time. And I'm going to share also a couple of stories, couple of success stories we had with Kafkistry. But now let's first see how we did things before we had Kafkistry. Just for starters, to show some numbers, back then when I joined the company, we had only 7 Kafka clusters. Now we have 22 and more about to come. On average, we had only 50 topics per each Kafka cluster. Now we have on average more than 250. We didn't have proper security, now we do. And since we didn't have proper security, we couldn't even know how many client applications from other services are connecting to our clusters. Now we know exactly, it's 262 at the time of writing this presentation, and there are 63 teams working behind those applications. And our model before to do any kind of operation on any cluster was that we were using command line interface, those scripts to either to create topic, to describe them, to list them, everything. And our flow when somebody needed new topic was the following. Requester would come in, he or she would then create a Jira task for creating new topic with a description where will this topic be needed, some estimates about how much the traffic is expected there, what is the needed time retention, and then somebody from Team Kafka would need to take this task, analyze it, and to propose appropriate number of partitions to calculate needed retention for that topic. And after that, to actually prepare the command to execute creation, and then we would be done. But what if there is some issue? For example, a requester not specifying all details that we need, or if the requester specified wildly big numbers that we don't have a hardware to support it, then we need to get back and forth with the requester to make some kind of deal. Okay, I don't need that much. I can lower the expectations, and only then we would be able to actually create a topic. And what would happen when we would need to install completely new Kafka cluster when spinning up a new data center? Then we would first need to find all the topics that will be needed there. And best bet was to search Jira for previous tasks, and fingers crossed that we would actually be able to find them all. And after we would find some set of tasks, we would still need to ask other teams for clarifications. Do you need this topic or not? Are the previously expressed expectation correct or not? And only then we would be able to actually create a big script to create everything and adjust all config values manually and execute it. And that was a lot of manual work. It could take, I don't know, almost a week to to arrange everything. And still, we would miss to create something, and other teams would complain after deploying their application that their topic is actually missing. So, obviously, this approach has a lot of issues, and we made a lot of mistakes. And for starters, we couldn't even know who is the owner of each topic and who is the responsible for the data. We would have a hard time figuring out where each topic is needed. A lot of topics had inconsistent config across different Kafka clusters. We didn't even know who made some change, who created the topic, who deleted something, or even why. And there was a lot of room for human errors, for example, mixing different configuration properties, or even operating on completely wrong cluster. You SSH somewhere, meaning you're doing something, but you are connected to completely wrong cluster. So having that said, we desperately needed some kind of solution to clean up this mess. And we started with the basic idea that we store topic configurations in a Git repository, which would then act as a source of truth for the desired configuration of all topics across all our clusters. And from there, we would have a tool which could be able to read this repository, and after that, apply needed configuration across all clusters where each particular topic is needed. We also implemented the other way around, so that Kafkistry can read the current configuration of all topics and then import them into Git, and that was done for the easy adoption onto the system, because we already started with having a bunch of topics and we needed import initially. And now let's take a look just for a brief example how the configuration looks like in a Git. It's some YAML file containing what is the name of topic, who is the owner, some kind of a short description. It also has a presence which explains where this particular topic is needed. By where, I mean on which clusters. And in a contrast, there is a corresponding UI input where this data is inserted. We do the writes through the UI, and we don't actually type those those YAML files manually. And of course, each topic has some basic properties specific to Kafka, like a partition count, replication factor, retention, and stuff like that. And for that too, there is a corresponding UI input where we enter those numbers, and this UI actually helps us by showing human readable values for those big numbers. And okay, let's say we have a topic in a Git, but not yet on the clusters. The Kafkistry will initially show that this topic is missing for all clusters where it's expected to exist. And after we actually create it, then the Kafkistry will show, okay, that topic has okay status, meaning that it exists as it should, and that it has a correct configuration as specified within a Git. And you may ask how we actually create the topic. It's just a matter of clicking on a button, and the Kafkistry will actually connect to all clusters that it needs to, and call some Kafka API to execute the creation. And in comparison, if we would write the equivalent command manually, we would need to write something like this. This is a like short example, but it's verbose and it's error prone, especially on those big numbers when you can accidentally type an extra 0 or 0 less, and it would behave not as desired. So what are some key benefits with this approach with Git? For starters, now we can track changes, meaning that we actually know who did something when, and with useful commit messages, we can even know why something was added or why some configuration was changed in the first place. By using UI, we significantly reduce human errors, as I already said. Omitting 1 0 in retention MS can lead up to significant time, for example, 12 hours in comparison to 5 days. We have a less manual work because all the computation and the execution is done by a tool. We just need to click on a button to actually trigger it. And with this, we have also better transparency, meaning that we can now quickly check for all our clusters, is the configuration what's in Git actually corresponding everything what's on all clusters. And since we are using Git repository for the storage, it opens opportunity that each change is actually committed into separate branch so that it can be peer reviewed before merging to master. And now I'm going to talk about what is the core functionality of Kafkistry and how it evolves over the time. Well, the core functionality is that on one hand, we have Git repository, which serves as a source of truth for all configurations. And on the other hand, we have a periodic scraping of everything what's on the clusters. And having those two informations, Kafkistry can show the status for each topic. Is it okay? Is it missing? Does it have some wrong configuration value? And stuff like that. And when something is actually wrong, then Kafkistry offers some operations in order to fix those issues, like creating missing topic, altering wrongly configured topic, and etc. And the evolution was following. We initially started with this core functionality as described so far, which was only intended to track everything regarding topics. We added new features as we moved along, and we got to the point that we do all our management operations exclusively through Kafkistry. We don't use those command line interface anymore. And we started with core implementation, and we added over the time a bunch of features, for example, like reassigning topic partitions, inspection of the consumer groups and their lag, management of consumer groups, meaning deleting them, resetting offsets on demand or seeking some offsets, management for access control list, which is needed for security, management of client quotas if we want to set some quotas on wildly behaving clients, metadata SQL, I will talk about that in a minute, and consuming messages directly from topic and showing them in the UI, and much, much more. This is not exhaustive list of all features. And now I would like to share a couple of success stories we had with Kafkistry, where this tool actually helped us save a lot of time and saving and reducing chance for making mistakes. Let's say you are in a situation where you want to add new broker on your cluster. You would do that in order to scale your cluster. And let's say that initially you start with 2 brokers or more, but for this example 2, and each of them has its own set of topic partitions. If you were to add a 3rd broker, this broker would be empty and not serving any traffic. if you want to get it into working state, we would need to reassign existing topic partitions in order to rebalance partitions across the new broker. And rebalance could look something like this. In this example, it looks quite simple, but when you have a lot of topics, each of them having a lot of partitions, it's a lot of manual work doing the reassignment of topics one by one. Fortunately, we have a Kafkistry that could generate all the reassignments for us. But the mistake that we did first time when we tried that in the production was that we rebalanced everything on a cluster all at once. And this caused a lot of stress on a cluster, even with setting appropriate throttling, because a lot of re-elections started to happen and a lot of writes on a zookeeper, which rendered our cluster unavailable for a couple of minutes. And the proper strategy to attack this problem was to do it incrementally. And by incrementally, I mean rebalancing only subsets of all topics in one round. And we can do it easily through the Kafkistry, where we go through some wizard where we pick some topics that we want to rebalance. And after that, the Kafkistry will show some proposal for the reassignments. And it will also show some statistics telling us how many topic partitions will be reassigned, how much data will be moved from each and onto each broker. And if we are happy with the proposal, we can then execute it. And we wait for the completion. And after it was completed successfully, we can repeat again until all topics are evenly distributed across all clusters. And after we are finished, we just need to verify that assignments are correct, and that will remove the throttling. The key trick here is that we limit the number of partitions that are being reassigned in one go, so that we don't introduce too much stress on a cluster at one single point of time. And for me, the biggest benefit was that we actually don't need to think very hard during this whole process, and that Kafkistry is there to do the heavy lifting for us. The second story I would like to share is about monitoring consumer lag. What is a lag? Lag is technically it is a difference between end offset in a topic and the last committed offset of the consumer. It tells us how many messages are still there for a consumer to process. I don't think that I need to say this, but this is super important metric to track. But the key question is how to obtain such metric. One approach could be that we expose it directly from the consumer application, but that poses some issues. For example, it needs to be done for every consumer application. And what if you have your consumer applications written in different languages using different libraries? You might end up with inconsistent format of your metrics, so that you don't have everything same for all your consumers. And the second approach is, of course, by using external application, what we do with Kafkistry. It works by Kafkistry periodically collecting end offsets of all topics, and offsets, last committed offsets for all consumers. And from there, lag is just difference between those two numbers. And Kafkistry by default exports such metric as a Prometheus endpoint. This is some example how it could look like, where we can see that for different partition, particular consumer group has a different lag. The biggest benefit here is that we have a universal and a common source of flag for all consumers within our system, so that it's all the same for everybody. Nothing is needed to be implemented on the consumer side, and this metric will be present even if all consumers go down, which wouldn't be the case if we were to collect such metrics from consumer instances directly. The next story is consuming and inspecting messages. This means that developers can simply open the UI and they can just on demand peek into the topic contents. This is useful for maintainers of consumer and producer applications if they need to check if something is there or is it correct. And Kafkistry offers various options when we want to start reading something. You can pick which topic on which DC, your starting point of read, and you can also filter specific messages if they match some custom criteria that you want. And the end result is some sample of message where it displays various metadata and pretty formats this, in this example, this JSON message. And you can note that it has some masked field. This is a feature if you care about security, that Kafkistry can mask some data which even developers aren't supposed to see. And the last story is about insights in our system by using metadata SQL. I would like to start with explaining this. As our number of clusters grew and number of topics grew, number of clients, number of producers and consumers, we started to losing our situational awareness, what's going on, and we couldn't simply easily know what's going on with our system. And let me just state this couple example questions. Let's say I would ask you, how many empty topics do we have? Or which topics have a message which contains field account ID? Or which of the old topics are being trimmed more than size-based retention in comparison to time-based retention? And questions like that. It's not that difficult to answer all those questions, but it's kind of impractical to obtain necessary information to be able to answer such questions. And our solution was to dump all metadata that Kafkistry has into some embedded SQLite database, and from there to expose it so that we can write custom queries against it. And now let's take a look in the example. Let's say we want to find out how many partitions and leaders each broker has. We could write a query that looks something like this. And after executing it, we would get some table output like that with concrete numbers being shown. It also has a built-in visualization in order to help us more easily to interpret those numbers. I could go on the whole day with those success stories, but I'm gonna keep it at this because we have a limited number of limited time. And the last thing I would like to announce that Kafkistry is now being open sourced, It's available on a GitHub, and it has a pre-built Docker image available on a Docker Hub. We officially tested this against Kafka versions ranging from 2 up to latest 3.2. So that's it. Thank you much for your time. If you have any questions, feel free to ask now or ping me later. And yeah.
Great. You've got a hometown crowd here.
Well, I'm glad to be here and to see that many people.
Yeah. Some nice support here. Who would like to ask a question? Nothing?
I think that.
Well, I'm just curious about the inspiration for this. I know you were having issues with the environments, right? With Kafka environments, and there's an issue with scaling Kafka environments. Have you seen this across the entire community? Or I know this is a specific issue to you. I'm curious what you've heard from other people as well.
I've actually heard about some cases where people actually don't have the scale that we do, but they had issues with tracking everything what's being changed in their system and to have this consistent configuration everywhere. And after we initially did this to help ourselves, but the motivation was that we can open source it in order to help everybody, because we recognize that this is useful for us, so it might be useful for somebody else, and we would like to help the community by open sourcing it and making it available for everybody.
Great stuff, Antonio. Thank you very much.